Hello, welcome. This is lesson 4.1a on simplifying radicals. A little bit later on, we're going to be talking about operations on radicals. So the product property of radicals says that if I have two numbers, let's say a times b under the radical, that is equal to the square root of a times the square root of b. And we can use this to help us to simplify radicals. Take, for example, number 1. The square root of 81 is the same as the square root of 9. Since 81 is 9 times 9, we can say that this is equal to the square root of 9 times 9. And that then would be equal to the square root of 9 times the square root of 9. And the square root of 9 is 3. And the other square root of 9 is also 3. And 3 times 3 is 9. And that this is correct. We can see that the square root of 81 is equal to 9. We can also use it to simplify radicals. So I can take the square root of 27, and I can write that as 9 times 3. And 9 has a square root, so I can rewrite this as the square root of 9 times the square root of 3, and the square root of 9 is 3 times the square root of 3. All right, let's look at number 48. So with some of these, it's good to practice what we have talked about a little bit in class about finding the prime factorization. So 48, I start with the smallest prime factor, which is 2. And if 48 is even, which it is, then it's divisible by 2. And 2 times 24 would be 48. And then 2 goes into 24, and it goes in 12 times, because 12 times 2 is 24. And then 2 goes into 12 6 times, and 2 goes into 6 3 times. Now 2 will not go into 3, but 3 will, and it goes in 1 time, and when you get to 1, you're done. So the square root of 48, we can circle pairs here. We can write 48 as 2 squared times 2 squared times 3. This is 2 squared, and this is 2 squared, and then we have 3. So the square root of 2 squared, the square root undoes the square. So there's 2, and it does that again on the second one. And then we have 3, which stays inside the square root because we don't have that. Anything that would simplify the 3. So 2 times 2 is 4. We have 4 square root of 3, and that would be equal to the square root of 48, but it's simplified. All right, 108. So we take 108. 2 goes into 108 54 times, and 2 goes into 54 27 times. Now 2 won't go into 27 because it's no longer even, but 3 will go in there, and it goes in there 9 times. Then 3 goes into 9 3 times, and 3 goes into 3 1 time. When you get to 1, you're done. So again, we're gonna circle pairs. And we've got a pair of 2s, and we've got a pair of 3s. And so we can write this as the square root of 2 squared times 3 squared times 3. And this would give us 2. We cancel the square root in the 2. It'd give us 3. And then we'd have the other 3 that's left behind under the radical still. 2 times 3 is 6. So we have 6 square root of 3. And that'd be your answer. And then the cube root of 24. Now this time instead of looking for pairs, we're going to look for threes of a number, 3 or more numbers. So here we have 24 divided by 2 would be 12. 12 divided by 2 would be 6, and 2 divided by 6 would be 3, and 3 goes into 3 one time. You get to 1, you're done. So now we have 3 2's here. So I can write this as the cube root of 2 cubed times 3. And the cube root undoes the 3, and so we're left with 2. The cube root of 2 cubed is 2. And then we get 2 square root of 3. I'm sorry, cube root of 3. And that would be what this is simplified. All right, let's look at the cube root of 108. We want to simplify this. Again, we're looking for 3's. Okay, so 108 Yeah, we've already done this. Let's look at what we had up above. We had 2 squared, 3 squared, and 3. So rather than going through it again, we've already written it up above. We're just going to write, this time it's the cube root of 2 squared times 3 squared times 3. We're just using the same prime factorization that we had above. 2 squared, 3 squared, 3. Yep. So this time we're going to write this 3 squared times 3, that's 3 cubed. So I'm just going to rewrite that as 3 cubed because we're looking for numbers in 3's. And so this cube root will undo this cube. The cube root of 3 cubed would be 3. And then we got 2 squared, which is 4. So we're going to have 3 times the cube root of 4. And that then would be finished. All right, number 7, we have the cube root of negative 125. So we have, we can take the negative out. When you have an odd index, you can take the negative out. So we have negative cube root of 125. And we're going to write 125, we'll write down its prime factorization. Since 125 is not even, we're not going to start with 2. We could start with 3. 5 plus 2 is 7, plus 1 is 8. So 3 won't go into 125. So we go to the next prime number bigger than 3, which is 5. And 5 will go into 125 25 times. 5 will go into 25 5 times. 5 goes into 5 one time. So here we have 3 factors of 5. So we can write this as the cube root of 5 cubed. And the cube undoes the 3, so we're left with negative 5. So we look at number 8. We've got the fourth root of 80. So this time we're going to be looking for 4 factors that are the same. So we write 80. 2 goes into 80. 40 times, and 2 goes into 40 20 times, 2 goes into 20 10 times, and 2 goes into 10 5 times. 5 is prime, so 5 goes into 5 1 time, and we're done. So I've got 2 as a factor 4 times. That's what I'm looking for. So we can write this as the fourth root of 2 to the 4th power times 5. And then once again, the fourth root undoes the 4th power, so we're left with 2 times the 4th root of 5. And that would be this simplified. All right. So the monitoring progress, I'd like to see how you do this on your own. Pause your video and see if you can do A and B. Do both A and B, and then unpause your video and you'll see if we got the same thing. Okay, here is what I got on those examples A and B. And then we're going to see how do we simplify radicals that have variables. And for that, we're going to move up to the top part here. So the same thing applies. We're looking for pairs. If you have a square root, you're looking for pairs. If you're a cube root, you're looking for threes. If you have a fourth root, you're looking for fours, and that sort of thing. So x cubed is the square root of x cubed. This is equal to the square root of x squared times x. X squared times x is x cubed. And the square root of x squared, that brings out the x, and then leaves the other square root of x inside the radical. And that would be simplified. 16x to the 5th. Once again here, 16, we'll sort of do these separately, the 16 and x to the 5th. 16 is 2 times 8, and 2 goes into 8. 4 times, 2 goes into 4. 2 times, and 2 goes into 2, 1 time. And so we have 2 pairs of 2s. Excuse me. So that's the square root of 2 squared times 2 squared times x to the 5th is x squared times x squared times x. So I'm just putting in pairs there. And then this cancels each one of these squares when you bring it out. And you have 2 times 2 times x, and then there's 1x that's left under the radical, so that would be the square root of x. And so 2 times 2 is 4, and x times x is x squared, and then we have the square root of x. And that's what this would be simplified. Let's look at number 3. Cube root of 32, x to the 6th, y to the 7th. So we have the 32. 2 goes into 32 16 times, and 2 goes into 16 8 times, and 2 goes into 8 4 times. 2 goes into 4 2 times, and 2 goes into 2 1 time. We're done. And we're looking for 3s, so I'm going to circle 3 of these. And for the x to the 6th, I can think of x to the 6th as x squared to the 3rd power, because x to this, when you have power of a power, you multiply the powers. So 2 times 3 is 6. Y to the 7th, I can think of that as the same thing, y to the 2nd power cubed times y again, because this would be y to the 6th, and then times y would be y to the 7th. So altogether here, I would write this as the cube root of 2 cubed times 2 squared times x squared to the 3rd power y squared to the 3rd power times y. And the cube root takes care of this cube and this cube and this cube when you take it out of the powers. And so this becomes 2. 2 squared stays inside the radical, so that would be 4. But let's see, then we've got x squared, y squared, and then we have inside the cube root, 2 squared is 4. We've taken out all of the x's, but we left one y behind, and so we put y. And that's what this would be. 2x squared y squared times the cube root of 4y. And that would be this thing simplified. Then we've got 52. So let's look at 52 separately. 2 goes into 52 26 times. 2 goes into 26 13 times, and 13 goes into 13 one time because 13 is prime. So we have one pair of 2's. We're looking at a square root. Remember, the index of a square root is 2, even though we don't write it. That's what would be there, is understood. Then we have, so let's rewrite this. The square root of 2 squared times 13 times x squared times x. That's x cubed. Y to the 4th is y squared times y squared. And z to the 8th is z squared. Let's say z to the 4th raised to the 2nd power, because 4 times 2 is 8. And so 2 squared, the square root cancels the square here, the square here, the square here, here, and here. And we're left with 2 and x and y again and z to the 4th. And then under the radical, we still have 13 and an x. So we want to multiply everything out. 2 times x, y times y is y squared, z to the 4th, and then we have the square root of 13x. And this would be the simplified form of that radical up above. All right. For the monitoring progress problems, pause the video and see if you get the same thing as I do after you've worked through them. Okay, so that's what we got here. And we can review through these problems when we're together in class. All right, so we're going to talk about operations with radicals. In this first part of the exploration, it's definitely worthwhile going through, but I'm not going to go through it with you right this moment. I would encourage you to think about the questions that are being asked here. Spend a little time going over this. and maybe answer some of these questions. Pause or rewind the video as necessary to ask yourself some of these questions. We're going to be going through some of these together on the next page. Okay, take for example, the idea of adding and subtracting radical expressions is very similar to where you're adding and subtracting like terms. You can only combine them if they are like terms. So if you take 3x plus 2y plus 5x, that's the same as 3x plus 5x plus 2y. And I've just moved the 5x over so that it's by the 3x, because those are like terms. And so I've brought together those that are like terms, and 3x plus 5x is 8x plus 2y. And that would be simplified. So if we compare that with the next example, if you got 3 square root of 2 plus 2 square root of 7 plus 5 square root of 2, my eyes go to the fact that both of these are square roots of 2. And so I bring them together, and that would be 3 square root of 2 plus 5 square root of 2 plus 2 square root of 7. And 3 square root of 2 plus 5 square root of 2 would be 8 square root of 2 plus 2 square root of 7. And that would be simplified. So when adding and subtracting radicals, you combine like radicals. You should also be sure to simplify before combining radicals. Okay, simplify. 7 square root of 3 plus 4 square root of 2 plus 2 square root of 3. These two are alike, so I'll bring them together. 7 square root of 3 plus 2 square root of 3 plus 4 square root of 2. 7 square root of 3 plus 2 square root of 3 would be 9 square root of 3 plus 4 square root of 2. And then I can't combine those any further because they are not like radicals. All right, number 2, 5 square root of 7 minus 8 square root of 7. And I'm going to do a little mental math here. 5 root 7 minus 8 root 7 would be negative 3 root 7. And then the square root of 11 cannot be simplified. That's the square root of 11. And they are not like radicals, so we leave them together, but separate. 10 square root of 5 plus the square root of 20. And I look at those two, and they don't have any like radicals, but they may if we simplify square root of 20. So we look at square root of 20, and we say 2 goes into 20 10 times, and 2 goes into 10 5 times, and 5 goes into 5 1 time. And so there's 2 2's there. So the square root of 20 we can rewrite as 2 squared times 5, or 4 times 5, which is 20. And the square root cancels the 2, leaving 2 square root of 5. So 10 square root of 5 plus 2 square root of 5. Now they're like terms. That gives us 12 root 5. All right, look at number 4. So we want to simplify the cube root of 81. For that, 81's not even, so we'd go with a 3. 3 goes into 81 27 times, 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 1 time. And so I can circle 3 of them because we're dealing with cube roots. And so the cube root of 81 is equal to the cube root of 3 cubed times 3. The cube root cancels the 3, leaving 3 times the cube root of 3. So here I have the cube root of 3 minus 3 times the cube root of 3. And I'm going to take this 2 cube root of 3 over plus the 2 cube root, plus 2 times the cube root of 3. And then I'll bring these two together, plus 5 square root of 3 minus, let's see, just so that you can see what I've done here, minus the square root of 3. All right, 2 square root of 3 plus root 3 of 3, that's the same as 1 root 3 of 3, and so there's 3 root 3 of 3 minus 3 root 3 of 3, and since these are opposites of each other and add them together, they cancel. And then 5 root 3 of 3 minus root 3 of 3 would be 4. Sorry, it's not root 3 of 3. 5 square root of 3 minus the square root of 3 is 4 square root of 3. And since these over here eliminated each other, they're equal to 0, so they don't add anything else to the sum, so that our final answer is this right here. Okay, I'm going to move on to operations with radicals. When we multiply radicals, 2 square root of 5 times the square root of 10. The product property of radicals says that the square root of a times the square root of b is equal to the square root of ab. And the quotient property of radicals says the same thing. If I've got the square root of a divided by b, that's the square root of a divided by the square root of b. So 2 square root of 5 times the square root of 10 Sorry, I'm having technical difficulties here. 2 times the square root of 5 times the square root of 10 would be 2 times the square root of 5 times 10, or 2 times the square root of 50. But we want to leave our answer in simplest radical form, so we take the square root of 50 and we simplify it. So I want to look at 2 goes into 50 25 times, 5 goes into 25 5 times, and 5 goes into 5 once. So I have, since we're dealing with square roots, we're circling pairs, so I circle a pair of 5s. So the square root of 50 is equal to the square root of 5 squared times 2. The square root cancels the square, and we're left with 5 square root of 2. So we have 2 times 5 square root of 2. 2 times 5 is 10. So we're left with 10 square root of 2. And that would be the final answer on that problem. Number 6. So I'm going to use the distributive property and take the square root of 2 times each of those problems. So I've got 3 square root of 2 times the square root of 2 minus the square root of 6 times the square root of 2. Now, the square root of 2 times the square root of 2 is 3 times the square root of 4. Square root of 4 is 2. So 2 times 3 is 6. And over here I get the square root of 6 times the square root of 2. That would be minus the square root of 12. 6 times 2, 12. And then I take 12 just to see if I can simplify it any. 2 goes into 12, 6. 2 goes into 6, 3. 3 goes into 3 one time. And I can circle a pair of those, so I can take the square root of 12 and rewrite it as the square root of 12 is the square root of 2 squared times 3. Square root cancels the 2, bringing it out as 2 times the square root of 3. So 6 minus 2 square root of 3. And that right there would be your final answer. All right, number 7. So we've got the square root of 12x over the square root of 16y squared. So we've already simplified this. Well, let's just a second here. The square root of 12x over the square root of 16y squared. Now, if we take these separately, we look back to the problem we had before here. We already simplified this square root of 12. That's 2 square root of 3. And so I can use what I've learned in the other problem. Say this is 2 square root of 3. And then there would be an x in there as well. X. Because I don't have a pair that I can take out, like I do down below, the y square root of y squared. The square root of 16 is a perfect square, so I can write that as 4. And then y, the square root of y squared would be y. Now, I want to simplify 2 and 4 now that they're out from under the radical. 2/4 is the same as 1/2, so I can write that as 1/2. So 1 times the square root of 3x would be the square root of 3x on the top. And on the bottom, we'd have 2 times y. And that would be this thing in simplest radical form. And number 8, we've got the cube root of minus 4 times the cube root of 2 times the cube root of 16. So I use the distributive property, and I get the cube root of negative 4 times the cube root of 2 minus the cube root of negative 4 times the cube root of 16. And you can only multiply when you have the same index. So since these all have the index 3, there's no problem with it multiplying them out, just like we did with square roots above. So here we get the cube root of negative 8 minus the cube root of negative 4 times 16 would be negative 64. the cube root of -8 is what number multiplied by itself 3 times is -8, and that would be -2. And what number multiplied by itself 3 times would give us 64, -64, and that would be -4. So we're subtracting -4. And so -2 minus 4 would be +4. -2 plus 4, and that would be 2. All right, if we look at number 9, we got 2 square root of 5 minus 4, the quantity squared. So this is equal to 2 square root of 5 minus 4 times 2 square root of 5 minus 4. So I'm going to recommend that we set this up with a box. I'm going to put 2 square root of 5 minus 4 and 2 square root of 5 minus 4. Now, in this top left-hand box, we're going to take the 2 square root of 5 times the 2 square root of 5. And the 2 times the 2 make it 4. And the square root of 5 times the square root of 5 make it square root of 25, or 5. So it's just 4 times 5, which is 20. 2 square root of 5 times -4 would give us -8. We just multiply the number times the number in the front. 2 times -4, -8, square root of 5. And 2 square root of 5 times -4 down here also would be -8, square root of 5. And then -4 times -4 would be positive 16. So I get 20 plus 16 minus 8 root 5 minus 8 root 5. Since they're both like terms, they combine and they would give us minus 16 root 5. And 20 plus 16 would be 36. So I have 36 minus 16 root 5. And that's what I would get. And then if I take number 10, the square root of the number 1, 2, 3, 4, 5, 6, 7, 8, 9 times the square root of 1, 2, 3, 4, 5, 6, 7, 8, 9. If I take the square root of x times the square root of x, I get the square root of x squared, which is just x. Or the square root of 3 times the square root of 3, I'd get 3. So if I take the square root of 1, 2, 3, 4, 5, 6, 7, 8, 9, or 123,456,789 times itself, the square root, I would get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at the practical application problem here. At the beach, the distance d in miles that you can see to the horizon with your eye level, h, feet above the water, is given by the equation d equals the square root of 3h over 5 times 2 times the square root of 2h minus 3 times the square root of h. Your friend is going scuba diving. They are on a boat 2 miles out from the shore. If you are 5 feet tall, will you be able to see them from the shore? So that means h equals 5. So we can put that in here into the equation. D is equal to the square root of 3 times 5 over 5 times 2 times 2 times 5 minus 3 times the square root of 5. And I can cancel those 5's inside there, so I get the square root of 3 here times 2 times the square root of 10 minus 3 times the square root of 5. The square root of 3 times 2 times the square root of 10 would be 2 times the square root of 30 minus 3 times the square root of 5. Now 30, 2 goes into 30 15 times, 3 goes into 15 5 times, 5 goes into 5 1 time. And that means I can't simplify the square root of 30. So at this point, I would pause for just a second here and take out a calculator to calculate what is 2 times the square root of 30 minus 3 times the square root of 5. So 2 times the square root of 30 is about 10.95, and 3.3 times the square root of 5 is approximately 6.71. So when you subtract them, you get approximately 4.24. And so 4.24 miles, you should be able to see your friend that's out on the boat that's 2 miles from shore. Okay, so practice some of these problems on your own. Make sure that you submit your notes to where it says turn in notes for 4.1. We'll see you in class.